In this example, we're looking at a ChiSquared test for the goodness of fit and starting with for a discrete random variable. Let's take a look at the example. It says Greg, a local corner shop owner, is looking into his opening hours to try and improve sales, particularly over the weekend. Greg claims that the number of customers that come to the shop each day is said to be proportionate to the number of hours that the shop is open. If this is not the case, Greg may need to reconsider his opening hours to maximise sales potential. The shop is open Monday to Sunday in a ratio of 6 to 6 to 6 to 6 to 10 to 10 to 3 hours. So Monday 6 hours and Sundays 3 hours. Greg decides to record the number of customers who come to the shop each day over a period of a week, and his results are shown in the following table. So there we have how many customers came in each day of the week. Use a ChiSquared suitableness of fit test at the 5% level of significance to test Greg's claim. And that's what we're going to do. So when we do any hypothesis test, we should be looking at 7 points. The first one being the hypotheses that we are looking to investigate, whether it is one or two-tailed, the significance level, the critical value, and then for the test statistic, we first of all need to work out expected values. We then compare these with the critical value and make a conclusion based on that comparison. So to start with, we need our hypotheses. Our H0 is always going to be that the suggested model is suitable. So in this case, our suggested model is a ratio, and we're going to say that that ratio is a suitable model for the number of customers in the shop. Our H1 is then the opposite of that that ratio is not a suitable model for the number of customers in the shop. Our second and third point are whether it is one or two-tailed and the significance level. The ChiSquared test for contingency tables and for goodness of fit is always upper one-tailed. We're always looking at that top tail. The significance level in this question is stated as 5%. Our fourth point is our critical value. So for our critical value, we need to know our degrees of freedom. Degree of freedom is n-1. And in this case, there are 7 possible days of the week somebody could come in. So our degrees of freedom is 7 minus 1, which is 6. We need to look this up at the percentage points of the ChiSquared distribution. So in the formula booklet, this is table 6. We go across our 6 degrees of freedom, and we come down at our upper 5% tail, which is 0.95, and I end up with that crossover point of our critical value, 12.592. Then to work out our test statistic, we next need our expected values. So to work out our expected values, we need our information in the table. We've got the days of the week. We can work out the probability of each of those and the expected values. So for this question, we'll be given a ratio of information. If we look at our ratio 6, 6, 6, 6, 10, 10, 3, there's a total of 47 parts in that ratio. And the probability of it being on a Monday is 6 out of 47. So looking at the ratio here, Monday is 6 and 47 altogether is 6 out of 47. That's the same for Tuesday, Wednesday and Thursday. For Friday, that probability increases to 10 out of 47 as it does for Saturday. And finally for Sunday, it goes down to just 3 out of 47. To work out our expected values, I need to know what my total frequency is. So in this question, if I add up the frequency of each of the 7 days in the week that he has recorded his results, we have just over 1,200 customers, 1284. So I'm going to multiply each of those probabilities by that sum of the frequencies to give me my expected values. So on Monday, we were expecting just under 164 customers, as we were on Tuesday, Wednesday and Thursday. On Friday and Saturday, we were expecting just over 273 customers. And on Sunday, we were expecting just under 82 customers. And those expected values are what are we going to compare with the observed values from the period of the week. So for our test statistic, we're using the O minus E all squared over E. We're going to do that for each of the 7 days and get a total. So for each one of these values, I've taken the observed value from the table, so 242. I've minus my expected value from the previous slide, squared that answer and divided by E to get a contribution to the test statistic 37.2. I'm going to do that for each of the 7 days of the week. And my final test statistic is the sum of those contributions, O minus E squared all over E, which I get to be 78.282. That's my test statistic. So point 6 is I need to compare that critical value with the test statistic. As we're doing a ChiSquared test, we should be looking at a ChiSquared distribution. I'm going to draw a line where that critical value is with that cut-off point, 12.592. Anything to the left of that 12.592 in the belly, we're accepting our H0. And anything to the right in the tail of that chi-squared, I am rejecting H0. So if that is my critical value, I look at my test statistic, which was 78.282. That's definitely going to be in the tail to the right-hand side. It's a huge number. So therefore, when I do my conclusion, I can say that we reject H0, and therefore there is significant evidence to suggest that the given ratio is not a suitable model for the number of customers in the shop.